Hey, Dylan.
Hi.
How are you tonight?
It's me. Hi, I'm good. How are you?
Good. So,
Good.
you're working on volumes?
I have like some story problems on like area of like pyramids,
Okay.
and so this is a problem. It says the Egyptian pharaoh Khufu built what we know today as the Great Pyramid in the ancient city of Giza, circa 2550 BC, and it said it stood 481 feet high, and each side of its square base was 756 feet long. And then
What was it? 750?
It said that the pyramid stood like 481 feet high, and each side of its square base was 756 feet long.
Okay.
And then like there's another pyramid. It says at its completion, this pyramid had a height of 215 feet and a square base of 344 by 344 feet.
Okay. And what do they want us to find on both of these?
They want us to find the volume on each pyramid, and they want us to like compare the two. So.
All right. Let's look at the first one. I'm going to try to draw a reasonable picture of it.
Okay.
Like so, right?
Mm-hmm.
And this height, the vertical height right to the center, is 481. And each side is 756. So what's the general formula for the volume of a pyramid?
Wouldn't it be volume equals 1/3 times base times height? Okay.
Well, not quite.
Okay.
It's 1/3 of the area of the base times the height.
Yeah.
Well, the area of the base is actually b squared.
Oh, yeah.
Okay? But the general formula is 1/3 the area of the base times the height.
Okay. So
not to be confused with 1/3 times the base times the height. Notice that if you didn't square that, you would have units of square feet. Right? And volume has to have units of cube feet. So we know right away there's something wrong with this formula here. So it's got to be base squared because it's
it just like has like a square base, right?
Right. Both of them do. So what's the volume of this one then? If we plug in here.
The volume would be 1/3 equals 756 squared.
And the height they mean is the vertical height, not the slant, not the slant.
Yeah, like the vertical height. So
you have a calculator? Can you give me a number on this?
Yeah, I'll get my calculator.
Okay.
So
the only reason we're going to need it is because they want you to compare
the
other one.
Yeah. Okay, so they want you to compare the volumes like of both of them.
Okay.
So like it's so the
is what?
The first the volume for the first one would be I got like 103,078 cubic feet.
Okay. Now let's figure out the volume of the second one, the smaller one. What do I plug in here?
Actually, how would you figure out the volume on the first one on a calculator? Because
you could do it directly. You could do 756 squared times
Okay.
481 divided by 3.
Okay, so 81 divided by 3?
Times 481 divided by 3.
Oh, okay. So, let's see here.
Let me do it real quick on my calculator.
Okay.
I get 2,749,000. Actually, get my other calculator
Yeah.
and do it.
Okay.
Okay, so 756. Whoops. 756. Reason I don't use this other one is because I'm not real good with the keys. Squared. So that's 571,000.
Okay.
And then times 481. Hold on.
Okay.
756 raised to the 2. Better write this down because I'm having trouble doing it all in one step on my
Yeah.
571,506.
Okay.
So I now want to take that answer.
Okay.
And multiply it by 481. 481 times 571, 536. And divide all that by 3. I get 9,163,000. Hold on. Let's take that back.
Okay.
It's 91,636,272.
Okay. So
The volume is
would be
91,636,272. So that's the volume of the big one. Now,
okay.
for figuring out the volume of the small, what do I want to plug into my formula?
Well, to figure out the volume of the small one, it would be it says this pyramid had a height of 215 feet and a square base of 344 by 344 feet.
Okay, so what do I want to write here?
So you want to say, volume equals 1/3 times base squared times height.
Okay. Now what do I want to write?
Now you want to write volume equals 1/3. And then you would put in parentheses 344, right?
That's correct. Square.
Okay.
Has to be square. Because that's the side line.
Yeah.
In other words, that S is not the area of the base. That's the B, really.
Yeah.
Okay? So I don't really like using B there. It's too easy to confuse it with the area of the base. And then the height is 215. So if we figure out what this number is, see, we're going to square 344. Gosh. That's 118,336. And then I'll multiply that by 215. You actually should try to figure out how to do this on your own also.
Yeah.
Just because it's somewhat difficult.
Yeah.
Okay, so this turns out to be 8,000,000.
Okay.
480,746 and change.
Okay.
Okay, so notice the difference between the volume of the big that was merely twice as, it was just a little more than twice as high, and the side length of the big was just a little more than twice the side length of the small.
Okay.
And yet the volume is more than 10 times as big.
Okay. So why didn't you subtract the first volume of that to 8,480,746?
Well, it depends on what she means by compare one to the other.
I think it means like to, because like at the bottom it says like difference in volume, so.
Okay. If she asks for the difference in volumes, then for sure you have to subtract those two.
Yeah, so I'll subtract right now.
If it says compare them, that doesn't necessarily ask for a difference.
Yeah.
If you're comparing them, you're just noticing that one is 91 million and the other is 8 million. So one is huge compared to the other.
Yeah.
But if she asks specifically for a difference, then that's for sure subtract them.
Yeah.
Okay.
So I'm subtracting right now, so 5, 3 minutes, 13, 9, 1, 8. I got 3,195,526.
Does that sound right?
Yeah. I'm gonna check it on the calculator. So
it's not in the ballpark. If I have 91 million and I subtract 8 million.
Oh, it'd be 83,000 or 83 million.
It better be close to 83 million.
Yeah.
Okay.
So let me subtract on the calculator. 6, 3, 2, 7, 2, 80, 46 equals 83,155,526.
That sounds right.
Yeah.
Okay.
Okay, so
Most important part of noticing is noticing that the volume is about 10 times the other, whereas the height was barely twice and the side length was barely twice.
Yeah.
So to get a volume that's 10 times, it shows you how rapidly it exponentiates when you go to volume.
Yeah, so now I get it now. You would do, like, for example, you would do base time, or you do volume equals base squared times height divided by 3.
Correct.
Okay. And then there's another story problem. It says, imagine you are designing a modern building that will be in the shape of a rectangular prism. Okay. You want the base and the height to be identical to that of the Great Pyramid. What will the volume and cubic feet of your building be? What if you chose to use the dimensions of Pharaoh Menkaur's pyramid? So that pyramid is the small one. So
what was the...
It was like asking...
340.
I was asking for... Yeah. So I was asking for like what will the volume like in cubic feet of your building be, and like if you chose to use the dimensions of like the second pyramid. So
Okay,
the small one.
There's our rectangular pyramid.
Yeah.
And this is the square base. This height, this height is going to be the height of that pyramid, which is 215.
Yeah.
Okay, so this dimension here is 215.
Yeah, and then it'd be 344 by 344 feet.
Okay,
That's
so
the base.
The volume of this object's going to be what?
It's going to be it equals base squared times height divided by 3.
So it's not divided by 3.
Divided by 1/3, right?
Not divided by anything. In other words, this is a rectangular. This is a rectangular pyramid. So a rectangular prism is merely the area of the base times the height. There's no divided by 3 because it doesn't go to a point. Notice notice the difference between this object and a pyramid. A pyramid's going to go to a point. So I would have to shave away an awful lot of this rectangular prism in order to get a pyramid. And the amount that I have to shave away is exactly 2/3.
Okay.
That's how one way to remember the volumes of objects that end in a point, like a rectangular pyramid. That's the same as the rectangular prism, only it's 1/3 times that. Same thing with a cone. If I take a right cylinder, what's the volume of that right cylinder?
The volume of the right cylinder will be base times height, right?
It's the area of the base.
Yeah, the area of the base times height.
Okay, so I could write it like that. But now if we talk about a right cone that goes to a point, what's the volume of that cone?
It will be area like volume equals area base times height divided by 3, right?
Exactly, because I have to shave away 2/3 of this material. If I was doing an ice sculpture and you gave me a right cylinder and said turn it into a cone, I would have to shave away 2/3 of the volume in order to get it to go to a point.
Yeah.
Same thing with a prism. So whatever the volume of the object that doesn't go to a point, that's uniform all the way up. Notice the difference between the right cylinder and the cone is the right cylinder is the area of that base everywhere you look as you go up.
Yeah.
Same area. So it's just the area of that base times the height. Same thing with a rectangular, what I call a rectangular brick, because if we wanted to know that the volume of this rectangular brick, I would take the area of the base times its height and not shave away any. But if I did want to turn that piece of ice into a sculpture of a rectangular pyramid, then I would have to shave away 2/3 of it. So knowing that, tell me what the volume is without doing the math, or at least tell me what the volume is compared to the volume of our small pyramid.
Okay, I'll do that right now.
Well,
so
just look at it and tell me what it's going to be.
Okay, so the volume for the square will be
how much bigger than this?
Base times height. So the base will be 344.
Hold on, just back up a second.
Okay.
How much bigger than our pyramid is it going to be?
How bigger than our pyramid is it going to be? It's going to be about...
Not about.
Yeah.
It's a perfect 3 times bigger.
Yeah.
You see why?
Yeah, because
if I wanted to build a pyramid out of this thing, I got to get rid of 2/3 of the material, which means the volume of this rectangular block has to be 3 times the volume of my small pyramid. So the only math I have to do is multiply that by 3.
Oh, so it would be 8,480,746 times 3.
Right, which is 25 million and change.
Yeah.
Okay, but notice that is so much easier than going back and having to square 344 again.
Yeah.
Multiply it by 215. Because the way we came up with this was to square 344, multiply by 215, and divide by 3. So to eliminate the divide by 3, I have to multiply this by 3.
Okay.
Okay?
Yeah, so like if you were to build a pyramid out of like that building that we just made, wouldn't you have to shade off like 2/3 of it to make a pyramid? Yes.
If you
and what I don't get though is like how you got like the 3, like
okay.
times 3.
Here's our rectangular building.
Okay.
Okay. If I put this small pyramid inside this thing, like this, here's the top of the pyramid.
Okay.
Goes down to there. Remember, the volume of this pyramid is the volume of the rectangular block. It's 1/3 of that.
Oh yeah, so like you got the 3 because it's 1/3.
If I know the volume of the pyramid, then all I have to do is multiply it by 3 to get the volume of the block.
Oh, okay. Yeah, thank you.
Okay.
And then so I got the answer for that page. So
okay.
I'll just write volume equals or area. Yeah. Okay.
Now volume equals 3 times the volume of the small pyramid. That's what you want to say. That's how you want to answer it. And then put the number. But show the teacher that you understand the concept that she's trying to get through.
Okay.
Which is that the volume of pyramids is 1/3 of the volume of the rectangular block. And the volumes of cones is 1/3 of a right cylinder.
Oh, okay. Yeah, so I put down like for a pyramid volume equals area base times height divided by 3.
Okay, that's correct. But the volume of a rectangular block is the area of the base times the height. No dividing by 3. And since
so just be base times height, right?
No.
Area base times height.
Area is very important. Don't say base times height, because when we talk about base times height, we're talking about 2 dimensions. There's base times height. Base is a linear measurement, usually. Area of the base is actually h times b, would be the area of the base.
Oh yeah. So that's to find area, but
this is a different height than in our 3-dimensional drawing. But that's why it's very important that you say the area of the base, not just the base. They're not one and the same.
Okay.
Okay.
Okay, so
Other thing would really be called S, a side length of the base. What is the side length of the base?
The side length of the base of the pyramid? Or?
No, that's okay. I was just saying that if you want to talk about the general formula for any of these, it's the volume equals the area of the base times the vertical height divided by 3.
Okay. Yes, that's what I have written down. Then I'm just writing down that, like with pyramids, like they equal 1/3 of a rectangular block.
Right, because the rectangular block, its volume is the area of the base times the height. No dividing by 3. Everything else is the same except we don't divide by 3.
Okay, yeah, thank you so much.
Yeah. Is that all you got? Is that all you need tonight?
Yeah.
Okay.
Yeah, I get it all. So.
Yeah, good.
Yeah, thank you.
Yeah, you're welcome. Okay.
Yeah.
Have a good evening.
Okay.
Yeah.
Thank you, you too.
Easier to get sessions with starting next week.
Okay.
Most of my students are out of school, so anytime you need any help, feel free to call.
All right. Thank you, Mr. Cohen.
All right, Dylan. Have a good evening. Bye-bye.
All right.